So let me explain the layout here. Here I took a snapshot of our drawing so we could look at it while we're doing our testing, and so what I have is the 3845 right here is this window right here. The 3750 is this window right here, and the Zotac box right here is this window up here, and all the MX2s, MX2 number 1, 2, and 3 are all right here. And that's kind of what I was talking about, that one BYOBU session. So I fired up a BYOBU session on the Zotac and on one of the MX2s. You can see down here at the bottom right here, I've called it CLI 8888, and that stands for Client 8888, right? And then there's CLI 8890, which is the window for the Client 8890 on the MX2, number 2, and then 8892 is the client for this guy. And then I have the servers. Server 8888 is this guy right here. You can see they're all on different windows, and you use F4 to see this little asterisk right here. I know it's going to be hard for you guys to keep track of it. I'll try to remember to tell you. But if you follow the asterisk, so I'm on the first window right now. If I go to window 2, you can see the asterisk moved. This is the MX2 number 2 client. And I just named these windows, and you can look at the manual for BYOBU. I have to rename, I think it's like F8 or something like that. Yeah, retitle a window. So I just titled these, and it kind of helps, clear up the desktop a little bit, because if we had to have all these windows open, it would be a mess. And likewise on the Zotac up here, I've got 3 server windows, server 8888, server 8890, and server 8892, and 3 client windows. And so this server is for this client here. So the server 8888 is going to accept traffic from this client 8888. This server 8890 is going to accept traffic from this client 8890, and so forth. And then that's for the northbound traffic, and then the southbound traffic, we got this client right here. This client 8888 is going to be going to this server 8888. And I hope that's not too confusing. I could have made these port numbers something completely different, but I was trying to not really simulate, but kind of pretend it's like duplex type traffic. So I just made the port numbers the same. I don't think the switch or router actually care as far as when it comes to load balancing. But so if you're wondering how I got into the different MX2s, it's really quite simple. All I did is you hit F2 to pull up a new window, okay? And that pulls up a window on whatever you started your BYOBU session on. Then I just simply SSH'd and whatever box I wanted. And then after SSHing in there, well, that's pretty much it. Then I just named the window, and if you want to close these windows, it's actually kind of funny. You just type in exit, and it'll close whatever window you're in. I actually was looking around in the manual trying to figure out how to nicely close it, and it finally dawned on me it was just a simple exit command. So let's take a look at some of the scripts. Well, I guess we'll start with MX2 number 1, and we'll look at the client script right here. So I go back to the MX2 number 1, and I'm just going to do a list here, and you can see I have the actually the client script and the server script, you know, in the same subdirectory in here, and I just have different windows for them. So if we go to server 8888 right here, which is, it's basically the, you know, same subdirectory. So yeah, let's take a look at it. So first we'll look at the client script. So I'll just cat this guy, and yeah, so all I did is I just VI'd this file, or you can use nano, whatever you prefer. And then I just put in this command, Iperf -c stands for client. This is the IP address of the server, so it's going to be the IP address of this guy up here, okay, the Zotac. And -u means use UDP. This -I2 means dump stats every 2 seconds. This -P8888 is what port to go to on this guy right here. And this -T99,999 is how many seconds to run the test. And there used to be a way to tell it to run forever, but I couldn't find it, and I don't remember what it was, so I just put a big number in there. And the -b is bandwidth, and I just put 10 meg. And that's what we're going to start with. And so let's go up here, and we'll look at the server. As you can see, I have all the scripts in one test subdirectory here in the Zotac. So we're just going to look, and what I do is I just have these different windows. I fire off one script in each window. So so let's look at the server right here. So I'm going to cat that guy. And okay, so it's the Iperf command. -s stands for server. -u is UDP. -I is to 2 is to dump the stats. And -P8888 is what port to listen on. And there is a way to bind it to separate IP addresses if you've got more than one network interface card in your box. But we don't need it because this one only got one. So so yeah, so what I'm going to do here is I'm going to go ahead, and I made all these files executable so I don't have to mess around with them. And why I put them in files too is because if you're tinkering, you can just VI this guy real quick and make commands and changes and that sort of thing, and just save it, and then you can run it without having to remember all the commands and retype everything. So I'm just going to go ahead and run this server. All right. So it's listening and it's waiting for the client. Let me go back to the... So before we get started, I was going to go ahead and fire up this client, and I was like, well, we might as well just start testing. So I kind of put together a little test plan based on what we were talking about on the whiteboard, and I can put this up on the I can link it in the comments or something if you want to have these for your reference. They're not real fancy commands. A lot of times what I do is I'll sit there and highlight them and then copy them and paste them in the window, and it makes it real fast for me. But I did want to have a little bit of a test plan here. So here's the commands we're primarily going to use to look at what's going on. I did want to show you how to set the load interval on it, and here's the test. So we're going to check make sure the router side of the lag is load balancing using a destination MAC. We're going to look at the switch side of the lag and make sure it load balances using the source MAC. And then we're going to look for any anomalies, and this is just with running normal traffic. I want to make sure, is it passing traffic? Is there's no jitter or delay or drops or anything bad happening. And then we'll do a little bit of capacity testing, and then we'll test this right here. This is probably should be up here with the load balancing test, but I'm not exactly sure we're going to get here today, so we'll see. I went ahead and I wanted to start with a 3750 load balancing test case just because it lines up a little better with our windows here. So I've already started the server, and what we're expecting to happen is, and we can do this real quick. In fact, we should do this. Let's go ahead and look at what some of the stats are, and put it in the wrong window. Okay, so 0 bits per second, 0 bits per second. Yes. And of course, another thing before we get started, I wanted to show you this load interval. So if you do let's see this 5-minute input. So if you do a config T, we're going to say interface range, and what I'm trying to do is what I want to show you is this 5-minute input rate is the bit rate averaged out over 5 minutes. Okay. And when you're testing, that is not acceptable. The lowest you can go is 30 seconds, and that's what we're going to do. Is I want to set this to 30 seconds. So I'm going to set all the interfaces here to load interval every 30 seconds. So range, let's see, it's 44 through 46. Okay. And we're going to say load interval 30. All right. I'm going to save that. So now, when we copy and paste that in there, yeah, now it's averaging it out over 30 seconds, which is the smallest number you could get. It'd be nice to do it every 10 seconds or something, but yeah, that just doesn't work. So yeah, so let's go check the router side real quick. I think I've already changed it on the router. Yeah, I already changed it on the router. So you can see everything is set. The input rate and output rate are all 0 bits per second, and what you're looking at is it's all three interfaces: fast 10, fast 11, and fast 12. And I'm just copying and pasting these commands right in here, and you know, that way I can kind of monitor them. I'll type the commands in. So okay, so you can see everything is 0, which is good. So we don't have to do the clear counters. The clear counters, it will clear out all the stats. So if I do, and we might do that just as a matter of course. So do a show int fast 10. So yeah, you can see all these counters have data in it. So if we do a clear count and then repeat that command, see how it clears everything out. So we can do that on both sides. It doesn't take very long. Clear count. All right. So so now what we're going to do, so for this first test, and I move these around. I want to start from the source, or from the switch. I want to start the northbound testing first. So what we're going to do is I've already fired up this server right here on port 8888. So I'm going to fire up this client right now, and I'm just going to set them for 10 meg. That should be well below the bandwidth of any of these pipes. And we expect to see it put it on, you know, one of the links. And we're going to look at that. So the server is running. So I'm going to fire up this client. Okay, and now you can see, so the client is sending 10 megabits per second. and this 2 megabytes is just how much data is being sent every 2 seconds. So, and over here you can see the bandwidth, the jitter. So, 0.18 milliseconds is teensy tiny jitter, and this is packet loss and total out of total number of packets. And then this will show if there's any lost packets. This would show a percentage of what was lost. Okay, and as you can see, nothing's getting dropped. Everybody's happy, and I'm sure the switch is going to report back the same way. So let's go to the switch. We'll copy in this. Copy, paste. Okay, so you can see that it's showing a 30-second output rate of let's see, it's in bits per second, so it's 1 2 3 1 2 3, so about 8.5 8.6 meg. But see, it hasn't been 30 seconds yet, so you can see it's only on one port, which is good. So it shouldn't be putting traffic on any of the others. Let's go look at this. Copy, paste, and there we go. Now we're at 10.2 megabits per second, and you can see there's other traffic, and that's because I'm SSH'd in to all these boxes, and we're actually using the lag for me to gain access to it, and that's because the test setup, I really should have had separate ports on MX2, but I didn't want to mess with it. And our goal anyway is I want to make sure it passes 90% of the traffic. I'm happy if we can get to that goal. Okay, so the other thing we need to check is let me go look at the router side now. Now we know from our drawing that well, port 40. This is port 44, 45, and 46. So we should be on the, I didn't write the port numbers out here, but we should be on the first port of the router, which is port 0. So let's take a look at that. And you can see it is not port 0. There's no traffic on port 0. It's coming out port 2. So what we've got is we've got port 44. It's cross-connected to port 2, and I actually stopped the video and went and looked, and sure enough, I have crossed all these. I must have just spaced out when I was connecting them up. And I'll have to look at the drawing, but I am pretty sure we did not design it that way. Let's see, here's a test bed drawing. Well, that doesn't show it. Okay. Well, I guess I didn't show it on any of them. But yeah, usually you start, port 44 would be matched to, the lowest ports match the lowest port. Apparently I completely crossed them. So that's actually another test that we did that actually showed us, yep, we crossed all our cables up. Is that a big deal? No, it does make it a little bit confusing. So I'm actually going to fix that before we move on. So I'm getting ready to unplug this, and it occurred to me that this might be an interesting test. So I know that I've got port 44 cross-connected to port 2 over here. And I really want 44 connected to port 0 and 45 connected to 1 and 46 connected to 2. So they're all kind of lined up like in the drawing. And so what I want to do is I'm going to disconnect this link right here so I can move it to another port. And what I'm wanting to see, so we already know we've got traffic going from let's see, where are we at? We have northbound, got 10 mega northbound traffic going from 44 to 2. So I'm going to unplug it, and so I can swap it. But after I unplug it, I'm going to come back here so we can see if the traffic actually recovers properly, and it should move over to another link inside the lag, which is a kind of a nice thing about having a lag. It provides redundancy. Okay, so I disconnected the link, and I didn't turn on term on, so I'm going to do that. Otherwise, we would have seen the alarm come in, which we didn't. Okay, that was actually in my list here, and I didn't do it. So, yeah, let's see where the traffic moved to. So this link right here, I disconnected it from the router side, so I disconnected it from port 2. It should be showing down. So let's get our commands out, and we'll look at the Ethernet switch side first. And 30-second output rate on 44 is now, well, it's showing 9 meg, but I just don't think it's had enough time to zero out. It should be 0. But you notice here's so it did move it. It moved it to port 45. And I'm sure we can check it over here. Here's the router. Copy, paste. Yeah, so he's moved it to the second port. So the good news is the second port, both the second ports match up. I just got to swap the first and the third ports. So I'll do that real quick, and I'll be right back. All right, so I moved the links. You can see here's all the console messages where I unplugged and plugged stuff in. And one of the things I thought was kind of interesting, and I actually wasn't expecting, is I think the traffic actually reverted back to the first interface, which it was originally on before I disconnected it. So let's go take a look at that. Let me clear the counters real quick. Clear count. And oh, I guess it doesn't clear this rate. So we just gotta wait 30 seconds. Let's go take a look at the router here real quick. And if need be, I'll stop for 30 seconds and we'll go take a look at it. You can see it's dropping down. See, the thing is it counts the number of bits it comes in and averages it over 30 seconds, which I kind of alluded to, and it can get real annoying. Can you imagine if that was a 5-minute wait? You know, you'd have to wait 5 minutes to get your actual traffic rate, and it's very annoying. And so, yeah, see, now we're up to 10 meg here. This is slowly dying and eventually should go away, unless there's some other traffic. But the point I was making is it moved it from the second port back to the first, and that's called revertive. And I was not expecting that to happen. I didn't set it to happen. It must do it by default. But I would have assumed it was non-revertive, meaning once it moved it over to the second link, it was done. So that's very interesting. We might have to see if we can find the setting for that later. But it's okay. I mean, it's not that big of a deal. It's just it wasn't expected. But this is, you know, sometimes testing really it really can shed some light on how your network's going to behave. Yeah, see, now the second link is completely showing dead, and we've got all the traffic on the first. So, all right. So the next thing on our list, we were going to check the load balancing. Or actually, that's the first thing on our list. But we had to fix the crossed link. So we got that fixed. And so now what we're going to do is we're going to fire up. I'm going to fire up the server on the Zotac for 8890. And then we're going to fire up the client, right here, for 8890. And I expect it, on the northbound, I expect it to use another link. So, because that's what it should be doing. It should be load balancing per MAC address. And this .17 will have a different MAC address than this .16. So, yeah, let's give that a shot. We'll go over here to the Zotac. We'll F4 over to the server. And, I mean, over to the next window. We're going to fire up the 8890 server. Okay. Now we're going to go back over to the MX2s. We're going to F4. Oops, sorry, that's the Ethernet switch. We're going to F4 over to the client 8890 down here. You can see the asterisks. And we are going to, let's VIM make sure that he's at 10 meg. All these are, I want him at 10 meg so we're not having any congestion problems. Let's VIM real quick, make sure he's at 10 meg. Yep, he's at 10 meg. And he's going 162, using port 8890. Okay, everything's good. So, let's fire him up. Yeah, he made it to the Zotac. I'm not seeing any lost packets. So we're getting the full 10 meg, which is good. The jitter looks good. So, okay, so let's go to the Ethernet switch first and see what where he put it. Okay, so this should be our first one, and it looks like he put the second one on port 46, or our third link. And the reason why it's showing low is because we've got to wait 30 seconds for Cisco to figure out how fast what the bits per second are. So let me copy this real quick. And we're getting there. And let's try that one more time. We're still waiting. So we'll come back to that in a second. Let's go over here to our router. And now that we've got our cables straightened out, we expect it to be on the third link as well. And sure enough, it is. And yeah, as soon as 30 seconds ticks by, these should go to 10 meg. The server's showing he's getting 10 meg, so I'm sure the router and switch will catch up eventually. Okay, there we go. So we got 10 meg, and I know it's over 10 meg, but there's a bunch of overhead stuff, and I just want to get in the ballpark of what it should be. So we'll go check the switch real quick. I'm sure it's probably happy now, or at least showing the right. Yep. Yeah. Excellent. So yeah, so it did load balance. So it put the first the 8888 client on the first link. It put the 8890 on the second link, and now we just have to do the third link, which will be the 8892. So we'll go fire up the server on the Zotac for 8892, then the client, and I expect it to show up on link 2. So let's give that a shot. So I'm gonna F4 over to server 8892 here, and where is it? All right, fire him up. He's on port 8892. Very good. I'll F4 over to him, and we want the client. I'm going to VIM real quick to make sure the bandwidth is right. Yep, 10 megabits. Excellent. Port 8892. And this is the right destination IP, so everything's good there. So let's fire him up. Okay. It's connected. He's transmitting. We're getting the full bandwidth, 10 megabits per second. The jitter looks good, and we're getting no packet loss. So excellent. So now let's see what our router and switch say. Now, of course, we're going to have to wait the 30 seconds again before we get the actual bit rate, but we are all familiar with that problem by now. Oops. Oh. Sorry, I did the wrong commands. And yeah, there it is. So he is on link 2. And I'm sure the router is the exact same way, so I'm going to call this a pass. And we can go look at some other stats, but the test for right now was, will it load balance? And using the source MAC. And the answer is yes. So the next test is going to be coming the opposite direction. And you can go in here and check the other stats. That's what I put all these in here. Sometimes I dump them all out and weed through them, but I'm not seeing any errors anywhere. So, and we're only running 30 meg on a 300 meg pipe, so or 3 100 meg pipes, so we should be good.